6.2, we're going to continue our lesson on exponents. In this section, we have a few additional exponent rules that you make sure that you memorize. For this section, what we're focusing on is problems that have parentheses and an exponent on the outside of the parentheses. The directions are simplify and write your final answer with positive exponents. Let's start with number 1. We have negative 4x divided by y squared, everything raised to the second power. The first thing you want to check to see is if you can reduce the fraction, and in this case we cannot reduce. And so what we do is we take the exponent on the outside and we multiply with the exponent for the 4. So 4 has an exponent of 1, x has an exponent of 1, and y has an exponent of 2. So you multiply your exponents. When we start with a negative 4, it should be put in parentheses. We have negative 4 squared x squared over y to the 4th. The parentheses around negative 4 are really important because if you forget the parentheses and we just write negative 4 squared, it would be different from writing the parentheses here. So your answer should be a positive 16. 16x squared over y to the 4th. The reason why we don't subtract our exponents here is because we do not have the same base. You have a base of x and a base of y. So we do not subtract since the bases are different. Number 2, same type of problem, except the exponent on the outside is negative 3. But you follow the same idea. We multiply the exponent negative 3 with the exponent 1 for the negative 3, with the exponent 1 for x, and with the exponent 2. Which gives us, again, make sure you have your parentheses, negative 3 to the negative 3 power, divided by x to the negative 3, y to the negative 6. Before I calculate negative 3 to the negative 3rd power, I have to make sure that I rewrite what I have here so that the exponents are positive. So before you calculate any value, rewrite the problem with positive exponents, which would be the x and the y move to the numerator, positive 3, positive 6, and then negative 3 to the negative 3rd, we write negative 3 to the positive 3. Notice I do not change the sign of the base. We only change the sign for the exponent. Okay, last thing, negative 3 to the 3rd power means negative 3 times negative 3 times negative 3, which gives us negative 27 in the denominator. X to the 3rd, y to the 6th, and we're done. Example 3. This one's different because if you look at the fraction inside the parentheses, we can actually reduce. We can use the quotient rule because we have the same base. And so if you use the quotient rule, what happens is I will simplify my problem and it'll just be m to the 1st, n to the 1st, raised to the 2nd power. Now we apply the 2, multiply, we get 2 squared, n squared, and that's our final answer. Number 4, I look inside here and I look at my fraction and I can reduce the fraction. We can use the quotient rule for the b. We have b to the 4th and b squared. You can subtract those exponents. So that gives us 2 ab squared raised to the negative 3 power. Now, negative 3 exponent we multiply with 1, 1, and 2. You get 2 to the negative 3, a to the negative 3, and b to the negative 6. Remember, before you calculate the value of any of 2 to the negative 3, you have to rewrite your problem so that all the exponents are positive. Since everything here has a negative exponent, I have to write 2 to the third, a to the third, b to the sixth in the denominator. What's left in the numerator is a 1. Now we can simplify. I know 2 to the third is 8. So we have 1 over 8, a to the third, b to the sixth, which gives our final answer. So remember, very important, 2 to the negative 3 should not be calculated until we have it written in the denominator. Same idea for the previous example right here. Negative 3 to the negative 3 power is not calculated until we have moved this term, made the exponent positive, and then we calculate it to be negative 27. Be careful with the signs and be careful with the negative exponents. We have 2 more examples. Okay, we have number 5, number 6. So for number 5, we have the parentheses, but no exponents on the outside of the parentheses. So what we're going to do is a little bit of review from what we did in section 6.1. You will multiply in the numerator. I can multiply 4 times 6, that's 24. And we have x to the negative 2, x to the 5th. Remember, you will add your exponents. What do I mean by that? I mean negative 2 plus 5. In the denominator, it's 9 times 2, which is 18. And then we have y to the first plus negative 1. Let's simplify. 24 x to the third over 18 y. Now 1 plus a negative 1 is y to the 0. We know that y to the 0 is equal to 1. So I can just replace y to the 0 with 1. 24 over 18 we could reduce by 6, which gives us 4x to the third over 3 times 1. What's 3 times 1? That's just 3. And we have our final answer. Last example. This example, we have the parentheses and the exponent on the outside, which implies we need to use the power rule. We will be multiplying our exponents. Do not forget that 3 has an exponent of 1 and 6 has an exponent of 1. We have to take care of the exponent on the outside of the parentheses first before you try to reduce. We get 3 to the negative 2 power, x to the negative 4 power, y to the positive 2 power, 6 to the negative 3 power, x to the positive 3, y to the negative 3. Okay, remember I said before we calculate 3 to the negative 2 and 6 to the negative 3, you have to rewrite your problem so that all the exponents are positive. So what we do is we're going to rewrite 3 to the negative 2 should be in the denominator as 3 squared, x to the 4th, y squared has a positive exponent that must stay exactly where it is. Now 6 to the negative 3 moves up to the numerator as 6 to the 3rd. X to the third stays where it is. Y to the negative 3 moves up to the numerator as y to the third. Next, now I can calculate. So 6 to the third is what? 6 times 6 times 6. If we calculate that correctly, we get 216. Y squared times y to the third, you have the same base. We add our exponents. We get y to the fifth, 2 plus 3. 3 squared is 3 times 3, 9. X to the fourth times x to the third, add your exponents. We get x to the seventh. The last thing that we want to do is we want to check to see if we can reduce our exponents. Or I'm sorry, if we can reduce 216 over 9. So if you look at this carefully, we can actually reduce both of these numbers by 9. So 9 goes into 216 24 times, and 9 goes into 9 once. So my final answer here is going to be 24 y to the fifth over x to the seventh.